Hello, welcome everybody. I'm really happy to see you, a lot of you here at CEU. So thank you so much for coming. It's amazing to see that so many people interested in women in data science. My name is Orsolya Vasarhelyi. I'm a PhD candidate here at the Department of Network and Data Science, and she's my co-organizer, Júlia Koltai.
I'm an assistant professor at Eötvös Loránd University and also a fellow researcher at the Hungarian Academy of Sciences.
So thank you very much for coming, and wow, I'm amazed by the amount of people who are here. So some super exciting things for us. We encourage all of you to tweet, to share, or anything what you want in social media using this amazing hashtag, WiDS2019. If you are not familiar with the Women in Data Science organization by Stanford, don't worry, in 2 seconds we're gonna have a beautiful video made by them, what we will show you, and then you will know more about it. Just a short outline, we're gonna start with this video, and then we will have an incredible keynote speaker, Aniko, Hannak, and then we will do a little live stream from Stanford University, where they actually already started the event, but we will join to their opening remarks. Then 3 other amazing speakers, a tiny break, 1 more speaker, and a panel, and then a networking event. So let's start with the video, and then I'll be back if it's...
It really seems like yesterday when there were 3 of us sitting around a table talking about this challenge that we saw, how to get more women into the field of data science and related fields like AI. We've seen that the numbers are pretty much stagnant for the last 10 or 15 years, percentage-wise.
And it's only when all these diverse opinions are brought together in a team that you can have a much higher chance of coming up with an impartial, unbiased answer that truly thinks about everybody.
It's more likely when I walk into a room that people won't automatically think I am the director of research. Who do they think you are? They might think that I'm just there to help out the director of research.
And so we started the conference to really showcase amazing women, high impact technical work in such a broad range of fields, from academia to industry, some in government, some in NGOs, and to show other people out there that, hey, there's lots of really cool ways that you can be involved in data science.
There's this really important thing that we as humans bring, and that's knowledge. Not all the knowledge we have is in the data. And this is where visualization is so important to data science, because it is the mechanism that helps people bring their knowledge to bear and to make decisions.
What are the recommendation algorithms that I can come up with that have particular properties? And then you go and you test how they actually behave.
The hardworking data scientist is indispensable, but the wise data scientist automates and scales.
The people who are present here are older than us and have already charted their path. That's been very interesting, because people have done incredibly non-linear things to get to where they are now.
Yeah. We went from 0 regional events around the world to now, nearly 200 in so many different countries. And it's one of the best things I can do with my time. And the WiDS Day itself on campus is my favorite day of the year.
When we started working on WiDS, we were trying to inspire others, and we were hoping that we would be able to inspire others worldwide. And what ended up happening is, with all these WiDS ambassadors, all of their creativity, all of their passion, all of their enthusiasm, that turned out to inspire us.
I believe that such events provide an exciting opportunity to increase everyone's participation in data science community, to share knowledge, and definitely to inspire others.
And it's a great opportunity to show the importance of data science in different fields and the valuable contribution that women give to this area.
My dream is to see more women in this scientific field,
because it encourages women to share their extraordinary work, have meaningful discussions, and become leaders in this exciting field.
I want to inspire other women in this science in Nigeria
and also want to encourage them to participate more in the field. Thank you.
So I feel WiDS is a great platform for all of us to come together and hone our skills in the technology that drives decisions across fields.
It's not just a conference. We have a datathon that we started last year, and then we also just launched a new podcast series, and it has some just fantastic interviews with women in many really different areas of data science.
If that is going to become completely data-driven over time, then you can't miss that opportunity. You've got to join in and have your say.
It's about you. All of you are empowered with the ability to do those experiments and to save the world.
Have an absolutely fantastic day here. Be educated, be inspired, and be ready to go out there and change the world.
So this is Women in Data Science. So thank you again for all of you for being here. And I just wanted to tell you that it was incredible that when Julia and me opened the registration, in 2 hours we sold out 150 tickets, and I got at least 60 emails that I want to join and how can I come to this conference. So thanks to our amazing sponsors, without whom we couldn't be here today, we managed to actually make this even bigger than we expected. Honestly, I thought it will be like a really tiny event with 50 people who are interested in data science, and no, it's much bigger, and we were really curious who you are, where is this big community, and because there is a big community, so we sent out a survey which was I wouldn't say 400 people actually answers, but 100 of them, because we wanted to know who are these people. I can tell you actually 96% of the people who register are women, so there's a lot of women in data science in Budapest. 55% of the respondents are junior. We don't have too much senior women in data science. We're gonna talk about it today. And our favorite programming language is Python, but we really like SQL because we need to. And also we use R as well. I'm on the Python side, but R is cool. And we have really diverse backgrounds, as you can see. We have, of course, mathematicians and statisticians, but from sociology to natural sciences, we are super diverse. We also asked the respondents about what do they think, how many % are women in technical fields. This is our beautiful distribution, what people said. I love the person who said 60%. I wish we will reach that. But the reality is between 15 and 20. Nobody knows, depends how you count it. And we want to boost it, as they just talked about it. And with the talks, we will just talk about how important data science is, and we need to include women here. And this is one of the platforms where we can actually showcase amazing speakers. So I really hope it's gonna be bigger and bigger event year by year. I'm really excited on behalf of CEU Network and Data Science that we could have it here, and I want other people to join us. And yes, that's it for my side, and I will let other experts to talk. But one more important thing, I promised at Stanford that we're gonna do a selfie with all of you because they didn't believe me there's that many amazing people who will come. No, I'm joking. So let me get Julia here on the stage, and you all should smile. Let's try another one. Wait, I'm not a selfie person. Okay, cool. So thank you very much, all of you, for coming here, and let me introduce our amazing first speaker, Hannak, who was actually doing her postdoc here at CEU last year, yes, but she's graduated at Northeastern University in Boston in computer science, and right now she's a professor at the Vienna University of Economics and Business, and also the member of the Complexity Science Hub in Vienna. She has a really, really exciting research about algorithmic fairness, and just welcome her, please. In the end of the talk, you will have the chance to ask some questions from her, so be prepared.
Hi, everyone. I thought I would start with a selfie or something, but as Orsi said, my name is Anja. I'm a researcher. I work somewhere in the intersection of computer science and social sciences. So basically, I ask social science motivated questions about people, society, but I use computational methods or data science methods. And I'm going to be, talking about biases in online labor markets in this presentation. So let me first introduce the kind of universe that I'm doing most of my work in. So in the past 10, 20 years, there has been this new ecosystem forming on the web, where companies such as Google, Facebook, LinkedIn, and so on, all are constantly competing for our attention, for our views, likes, and so on. So essentially what's happening is, as users are interacting with websites, there's more and more data collected about them by these platforms. So what they search for, where they go, what they shop, and so on. And then all of this data is fed into so-called big data algorithms that then try to shape the content to the user's taste. And of course, there is a feedback loop here. So the more users are interacting with the websites, the more data is generated about them. And then before they notice, the content on these websites might look completely different from what other people see. And this might lead to problems such as the filter bubble or echo chamber, which you might have heard about, essentially a phenomenon where people are only exposed to content that already aligns with their views, and this creates kind of a polarized society. Or algorithms that are discriminating because they pick up on human biases in society. And this is what's going to be my focus in this talk, discriminatory algorithms. So I wanted to show a couple of examples that you might already be familiar with from the media. For example, racial biases were found in the ads that are served by Google and Facebook, or articles are warning about discrimination in the black box algorithms that are used for predictive policing or making parole decisions. And various forms of discrimination were found on Uber, Upwork, and other kinds of sharing economy platforms. And the list really goes on, so there's more and more examples in the media every day. But one thing you might notice is that a lot of these examples have to do with the labor market in some form. And this is actually not a coincidence. So the internet is fundamentally changing the labor economy. More and more people search for jobs online, so I'm sure all of you have a LinkedIn account. Almost 50% of the US workforce is actually applying for jobs these days online. Freelancing is more and more common. And accordingly, there are more and more and diverse platforms that serve this need. And in theory, these platforms might actually democratize the labor market. So of course, you imagine you just go on one of these sites, you find a lot of different job opportunities, and even more, these opportunities should theoretically be the same, independent from your location, from your class. But the problem is that there's actually no transparency on how these platforms work, what kind of big data algorithms they use. And as I mentioned, there are more and more concerns with algorithms discriminating. And the problem is that while discrimination is very much regulated in an offline context, so there's a big history for that, in the online context, policymaking still has to catch up and protect employees. So in this talk, I'm going to mention 2 studies that I have done. So basically all these little icons are platforms that I studied in some form. But the 2 major ones that I'm going to be talking about are job search sites and online freelancing platforms. So the first thing I wanted to say about job search sites is that while you might be thinking that these platforms are there for you to find a job, it's actually a way for recruiters and companies to get access to a large pool of potential candidates. So if I'm a recruiter, I can go on one of these websites and search for, let's say, software engineers. I can define the location, and then I can even set much more complicated filters about people's expertise, their education levels, and so on. And then the website returns with a list of candidates that they think might match my expectations. Usually it's thousands of people that are shown in this list. And you might notice that they are ranked by, actually the website tells me, by relevance. We of course don't know what this means at all. But you might imagine that the person on the top has much better chances to actually be seen and be contacted by a recruiter and then eventually getting a job than someone on the bottom of this list. So it's actually quite important to know what people are ordered by. And this is where some sort of bias might come into the play. So there is an algorithm in the background that tries to take into account a lot of different features. And even though demographic information, for example, race and gender, are not explicitly taken into account by this algorithm, there might be some features that correlate with gender and race, and then the algorithm might slowly pick up on this bias, and let's say rank men towards the top of the page. So essentially, my question in the study was, how does gender relate to the position in the search result list? And you might notice that I didn't ask the question, are men and women ranked equally, or do they have equal opportunities? And this is why, because it's actually quite hard to define what would be fair in this situation. So do we want people with equal CVs to rank equally, or do we just want men and women on average to rank equally? So the two basic concepts that I'm going to be looking at is group fairness and individual fairness. What group fairness means is that men and women are ranked equally across a list. So what we say is that there's no statistically significant differences in the distribution of ranks assigned to female and male candidates. But this is, of course, very hard to actually make happen in practice, because women often face biases and discrimination in earlier phases of their careers. So maybe their CVs would actually not look the same by the time they get on one of these job search sites. So I'm also going to use a much simpler definition. Let's see whether the algorithm assigns adjacent ranks to candidates who have exactly the same observable characteristics, regardless of gender. And I'm going to investigate these two definitions on 3 different job search sites. So these are large US-based job search sites: CareerBuilder, Monster.com, and Indeed.com. What I did, essentially, I signed up pretending to be a recruiter, and I got access to the search functionality of the website. I searched in 20 different US cities for 35 different job titles. So there's a huge variance in the kind of job titles I searched for, ranging from kind of low-paying jobs like a truck driver to software engineers. And I essentially capture all the users that show up as in one of these search result lists. And this is giving me something like 800,000 users overall. So, and then what can we extract from this data? First of all, I get some sort of demographic features, such as the user's location, name, gender, and so on from the profiles. And then I also have job-related experiences, people's education experiences, their current job, and so on. And the next, I'm also defining something called relevance, because, of course, when I search for a software engineer, I expect software engineers, of course, to be on the top, but let's say a truck driver is not very relevant to that query. So I also define something called relevance of the skills or someone's current job to the actual search that I made. And then finally, I also capture people's position in the search results list. So I want to see where they showed up in the search result. And then from this data, I'm going to test for these 2 definitions of fairness. So the first one was group fairness, where essentially for every pair of job title and city, so something like software engineers in New York City, that would be 1 pair. So across all these pairs, I'm making this test of whether the distribution of men and women is significantly different in that list. And essentially what I found was that for 18%, 13%, and 18%, so this is across the 3 websites where I collected the data from, I found significant differences in the distributions. But of course, for the categories that are very traditionally masculine or traditionally feminine, these percentages can be much higher. But then actually these results don't really say anything about the algorithm yet, because this just means that potentially, let's say, women have sort of weaker CVs. So what I do next is I actually compare the people with exactly the same characteristics. To do this, I use a regression model. So essentially what I do is I try to predict where people will be showing up in this search result list based on their experience, their education, the last time they updated their resume, what their current job is, and so on. So essentially every variable that I can observe in someone's profile. And I control for all of these variables. What I find is, unfortunately, gender is still significant in all of these three sites, favoring men. So the takeaway from this is that there is some kind of bias that the algorithm picks up and recreates here. So if I'm a new recruiter joining this site, even though I might not have any preconceptions, already there's going to be a difference in how men and women are presented to me. And this might actually get reinforced over time. It's very hard to know why this is happening. So it might be that, let's say, the algorithm takes some variables into account that we cannot see on people's profiles, for example, click-through rate or something like this. But the problem is that it really affects how people hire. So the next study that I'm quickly going to show is about online freelancing marketplaces. What does one of these sites look like? So let's say I'm organizing a huge event and I need some help with that. I can go on one of these websites, freelancer.com or taskrabbit.com, and I can search for event planning. And then the site gives me all these workers who are happy to help me with this event planning. If I click on someone's profile, I see even more information about them. So I see a little profile picture, their name, the description they have, how many jobs they have done in the past, and so on. And then I can even see the reviews that other people have left for them. And basically, you can see that both in the process of picking a user from this list or leaving a review for them, or how these people are presented in the algorithm, there is some potential for biases to occur in this decision process. And then this could get potentially reinforced by the algorithm. So my goal is to kind of disentangle, measure whether there are biases and then disentangle where it's coming from. So the main question is, how do demographic features relate to, first of all, this recommendation system that's in place here, so reviewing each other, and then also the position in the search result list page. I collected data from two websites here, TaskRabbit and Fiverr. TaskRabbit is a place where you can hire people to help you with household-related tasks, so moving, shopping, cleaning. And on Fiverr, you can hire people for small online tasks. Again, I extract some user features from this data, such as the worker's age, education, and so on. And I also capture their gender and race. I also see their experience on the site itself. So these are kind of dynamic variables that evolve over time, how many tasks they have completed, how many ratings they have received, what is the actual text of the reviews. And then finally, I capture the position of each of these users in the result list for a given query. So the first result I wanted to show is similar to the previous study. I'm looking at where people show up in the search result list. This is from the site TaskRabbit. And essentially in all these four categories, handyman, moving, party, shopping, men show up higher towards the top of the page. It was quite surprising to see this. So I expected something like in the shopping category, maybe women would get higher. But then again, to do this analysis properly, we actually need to control for how experienced users are, because this might be happening simply because, let's say, men joined the site earlier. So we have to control for these kind of differences. So the proper way to do is to actually build a regression model. So don't worry about the table. It's mostly to show what kind of variables we used in this analysis. So we actually take into account the rating that people have, how many tasks they have completed in the past, how long they have been a member on the site, and so on. But even after controlling for these variables, race and gender seem to be significant. Specifically, Black workers rank lower in the search result list than white workers, and being a man is even worse in the case of Black workers. And there's a couple of different sort of success measures that one can take into account. So not only where you show up in the search result list, but also, for example, how many reviews a worker received, or how many of their tasks have been evaluated, what is the actual rating score that they have received, and so on. So for each of these, we can build similar regression models. And essentially, in most cases, we find gender and racial differences. But what's interesting is that the extent and type of inequality highly differs based on which site and which job sector we're talking about. This is interesting because it means that the design of the website and how the algorithm works, what features it takes into account, really can affect how inequalities evolve. So just to quickly conclude, I hope I convinced you that there is new and exciting mechanisms for inequalities to emerge on these new online platforms, and that we require new measurement techniques to detect and quantify them. This is very exciting for researchers. I believe that we not only need external auditing, but kind of internal auditing from the companies. Actually, most of what I'm doing is in some sense illegal because I need to hack into the companies and collect all this data against the terms of service. But I do it because I believe it's important. But I hope that more and more companies will actually do similar internal audits to establish transparency. And then, of course, there are a lot of open questions, so this is going to be a long process until we really get to a definition of fairness. We have to come up with mitigation strategies for the current issues and figure out how to prevent future problems. And then, of course, it's a big open question whose responsibility is to fix problems once we discover one, because we don't really know, is it the company who has to fix it, or is it some external policy that has to apply in these cases? But for those of you who work at companies here, just keep in mind these results and see how they apply to the websites and kind of the design that you're working on or the algorithms that are in place at your company. Also, if you have exciting data or research ideas, feel free to reach out to me. And thank you. Of course, this work wasn't done by myself, so I wanted to put my collaborators on here. And thank you, and happy to take any questions.
We have microphones. So we have microphones. Questions? We're gonna bring it to you, don't worry. It's a really good opportunity to ask questions from Ancho. Okay, I have, okay, here's one brave person here. Here you are.
Is there a source available for offline discrimination that can be used to compare online discrimination with real-world offline discrimination?
It's actually a really good question that we talk about a lot in the community. It's very hard to find the right baseline. So, of course, in the offline world, most of this discrimination is measured in terms of wage gaps, or you can do these audits where you send exactly the same resumes with just gender changed on them, and these are the kinds of studies that are done. And I really meant it when I said we need new kind of mechanisms to measure inequalities, because it's very hard to compare against offline against online.
Have these companies reacted on your results?
Sorry, I didn't hear.
Have these companies reacted on your results in any form?
Yes, so I usually, when I conduct such an audit, before I publish the paper, I contact the companies. In most cases, unfortunately, I get mostly adverse reactions. So they're kind of scared to get in the media and to be attacked. There were some good examples where they said, oh, we didn't know, we're going to fix it. But sometimes I don't even get reactions.
Is there anything what job seekers can do?
Sorry, I didn't.
Is there anything what job seekers can do?
Good question. I think there is, but I'm not sure I personally recommend it. But there is, for example, such a thing as resume whitening, which is very common in the US. I don't know if you're familiar with the term. I would say, I mean, you can also kind of cheat on your resume. I heard that some people, what they do is, if your resume is a PDF, you can actually put Harvard or some keywords on it with an invisible, and then certain automated systems would actually pick up on that. But okay, so I'm sure that doesn't really answer you.
Okay, so I would reformulate my question. So in your opinion, it is rather on companies than on individuals who should tackle this problem?
I believe so, yes. So I think in this case, the user on the site, so when you sign up to LinkedIn, let's say you have absolutely no control over what's happening to you. And I think awareness helps to some extent, that you might, one person might be exposed to, might get a different amount of attention or might be exposed to different companies just because of certain keywords on the resume, but I think it's really not up to the individuals.
Thank you.
More questions?
It's not a question, it's just a comment for your question. That an HR person told me that men says more than women about themselves. So actually, when they feel 50 or 60% that they are okay for a job, they apply. And a woman says for 80 or 90% or 100 or just, so it's a. So I think men says more about themselves and women says less. So it's.
Thank you very much for the interesting summary. I think it's quite alarming what you have presented. And my question is, what the reason could be behind those biases?
What is the reason behind those biases? What do you think? I like to ask everybody to speak super into the mic because we are having a live stream. So I hope there's a bunch of people watching us online and they will not hear us otherwise. Thank you.
So I'm not quite sure what you refer to by those biases, but I'm assuming more the online part than the offline because we know about statistical discrimination. I think there's really, so it's really kind of like a pipeline. So different groups of people already have access to kind of different websites. People get recruited to certain sites with different kinds of advertisements, so they already enter the platform with a different expectation. They behave differently because they come from different cultural backgrounds. So it's really, we have to think of it in terms of a pipeline. And then also the same applies in hiring. I could be biased by a profile image when I click on someone. I could be biased when I make the decision who to hire, when I leave the reviews and so on. So there's really a lot of little things that add up to maybe certain minority groups having less chances.
We have time for one last question, which is here. I can see it.
Hi, thank you for the introduction and your summary for the research. I have a question regarding the other categories, for example, for people who don't identify themselves as a female or male. Does that actually create a problem for them and create more biases towards them within the algorithm, or you didn't take that into account in your research?
So I try to take this into account, but it's very hard because I think what matters here most is kind of the perception about people, and I think still most of these platforms only allow, unfortunately, for a binary category, and this is kind of how people are taken into account also on the other side. So I mostly focus on what the perception based on the profiles about these people are, and that's usually binary.
Okay, I will use my privilege to ask one more question, which is, what do you think about this trend that people think that these algorithms, what these like big monsters or whatever companies are using, I'm joking, should be like actually published? So to be sure what's happening within the machine. You think we will ever reach that, or we will never reach that, or you think it's a good idea?
It's a very interesting question. I believe that it would be actually kind of a first step if we would see what's going on inside the algorithms. There are a lot of problems with this. The first one being that whenever something like this gets published, it immediately gets attacked in the media. So companies are not actually doing it because they're scared. Even if you publish such an algorithm, it's very hard for a general user to understand what's going on inside it or what it even means. So there's a whole research direction called explainable AI that's about trying to make it explainable to the users. Yeah, but I definitely do think that transparency is kind of the first step. Yep.
Okay, thank you very much. Let's thank for Ancha for this amazing talk. We are about to start a live stream, I guess. It's gonna happen from up there. Amazing.
Welcome to WiDS! Wow, it's so wonderful to be here again with all of you, not just here at Stanford, the beautifully packed room full of women, but also some men. You see that? A big shout out to the men here today. Come on. And we're not just here, we're at regional events around the world, and you'll hear more about that today. And also a big welcome to those of you watching us on the live stream. We're live streaming today. We're here to celebrate today the outstanding work done by outstanding women. And today here, just in this room, we have, let's see, checking my numbers, over 50 universities, over 80 different organizations. And many countries. We've got people from South America, from Central America, from Europe who are here, and Asia, Africa, who are here specifically for the main event here at Stanford. So I hope you will meet each other today and mingle and network and find that support that we're really trying to achieve here.
Yes, it's wonderful to see everyone here, and we are so excited to see how much WiDS has grown in the last 4 years, really involving people around the world. And in fact, today we're particularly excited because we have 16 speakers, amazing technical speakers, and they come from 7 different countries across 5 continents. So really at the core, this is an international conference representing so many different perspectives. And it's great to see data science going global.
So in addition to everyone who is here at WiDS Stanford, the speakers and the attendees, there are hundreds of speakers being featured at worldwide events. And at those events, there will be 18,000 attendees. Moreover, we actually expect to have 100,000 participants, both online and in person, with this conference.
And it's been so wonderful for us over the years to get to know people from all over the world. I just want to tell you one little anecdote. We had a student who watched the live stream of our very first WiDS in 2015, so this is our 4th. And she got so inspired by this that she applied to Stanford, to the program ICME that I was directing at the time. She has now finished her master's and she works for Microsoft Research here in the United States. And she said she would never have made the jump from her village in India to the United States if it hadn't been for WiDS.
What I love especially about WiDS is coming back, meeting new people, and also connecting with longtime friends and colleagues in the data science community. We say WiDS aims to inspire and educate, and also to support women in the field of data science, just like everyone here is today, connected with each other. So I actually look out and I see a lot of familiar faces, some people who I met 4 years ago at the very first WiDS in 2015. And I love being able to say, hey, see you at WiDS, and connecting with everyone, and I can't wait to catch up today.
So we've heard from students who have pursued different degrees and they've actually honed their skills. We've also heard from professionals who have changed the trajectory of their careers. And we've also heard from people who have wanted to share their knowledge with their communities, all as a result of being inspired by WiDS. But we want to hear your story. We want to know what you've learned. We want to know what your experience has been, and we want to hear your story. So please share your story with us on social media by using the hashtags WiDS2019 and WiDS story.
Get your phones out.
Get ready.
Just like in the Oscars, we have a lot of thank yous as well that we want to do just at the start of the day. So here's my thank you list. So let me just thank my mom, who's watching from the Netherlands. No, seriously, I want to thank our Stanford collaborators and sponsors, particularly ICME, who has once again helped this year with WiDS, and the School of Engineering, and we're going to hear from the School of Engineering a little bit later as well.
And so I also want to thank all of the WiDS ambassadors worldwide. We actually have several of them here today, but I also want to speak to them via live stream and say thank you for all of your work of bringing WiDS to your cohorts, to your communities, to your colleagues. I especially want to thank some of our WiDS collaborators who have organized multiple regional events.
And we want to give an especially huge shout out to all the sponsors of WiDS this year. WiDS takes a lot of effort, a big team of people to do the conference and also the other programs throughout the year that you might have heard about, the podcast series, the Datathon. And we really couldn't have done it and had this global impact without all of these fantastic sponsors. Definitely they support us with the funding, but much more than that. They give very generously of their time, many creative ideas, their enthusiasm, their leadership, and we just want to recognize all of them, many who are in the room today. Maybe if you could stand up now if you're part of these companies, so we can just give you a nice round of applause. Thank you all.
And we are also super thankful for our sponsors, so let's actually thank from our side as well for our sponsors. So we had SAP, BlackRock, and Starshema as our key sponsors, and also we are super thankful for CEU for being here, so thank you very much. So let's go back to our speakers. And I'm really excited to present our next speaker, who is Eszter Bokanyi. She studied physics at the Eötvös Loránd University and in the University of Berlin. And she specialized in statistical physics, which is really close to my heart, so it's nice to see that. She's a graduate student in ELTE right now, where her main research is studying how social phenomenon can be captured through statistical physical methods. And she's also joined the ENET lab recently, and her interdisciplinary research is taking there in the Hungarian Academy of Science as well. So let's welcome Eszter on the stage.
So welcome everyone.
it is quite lucky that I'm speaking after Ancha, because the work I'm presenting now is a collaboration with her, and it directly follows from biases in online labor markets, I think. It is just another type of these online resources that we recently use very much in our everyday lives, maybe not so much in Hungary, but ride-sharing or food delivery services are gaining a large share in the market recently. So for example, here are some companies like Uber or Lyft who are taking the place of traditional taxi providers. But these companies or this kind of employment also raises some serious issues. For example, there have been news in the media that Uber is not treating its workers really fairly. Recently, a journal called Financial Times launched a little game which is called an Uber game, and that tries to simulate some days in the life of an Uber driver. So we can imagine that the driver goes, sits in the car and receives through an application some kind of notifications that, hey, here's a passenger that wants to go from A to B, pick it up, and then the driver faces some very serious decisions. For example, whether to stop working after 7 hours of work and go dining with friends, or to keep working, or to pick up a sick kid from school, or to keep working. And at the end of the game, we see that the poor driver cannot meet his financial needs and goes bankrupt. Basically, the game shows how exploited these workers can be, and it also shows that these drivers have very little control over what jobs they receive, and they also have no control over how much income they receive, for example, compared to others, because they are pretty much isolated. And moreover, the companies that distribute these rides algorithmically, they do not publish the algorithms. They are proprietary. And also, while they have all the data in the world, so they know the position of the drivers, they know the positions of the passengers, they know how much drivers earned, this data is not visible for the workers itself. So it creates kind of an information imbalance, which is not really fair. This central data that the companies have can serve for them to be able to maximize their income, but they won't look out for drivers' interests by themselves. So Uber drivers have already, for example, striked, and there is much research going on in the social sciences to discover how unfair these systems are. But there is still the lack of data. And since I am a physicist, I was trying to tackle this problem by simulating such a ride-sharing system. And then we have all the data that we would like to, and we have access to this data as well. Therefore, we've created a simplified city environment where we can control a wide range of parameters, and we can arrange different setups, and therefore we can check whether, for example, incomes will be fair for the drivers, and we can also propose strategies how to take workers' interests into account. How does such a simulation look like? Basically, there's a square grid that represents the city, and on which grid some taxis are able to move. And then we have some passengers that want to go from A to B, and we want to pair these passengers to the taxis. When I was creating this simulation first and I had to test it, I was delighted because my first phone ever was a Nokia, and I guess you all know Snake 2 on it. So I've basically written a Snake 2, which was a great experience. An automatic Snake 2, yeah, that goes for the apples by itself. So taxis go, pick up the passengers, then as I'm running the simulation, they kind of go along some path, And when they've reached the destination, they drop off the passengers, and then they again become available for other passengers' requests. What is at the core of this whole system is the automatic algorithm that pairs the drives to the requests, to the passengers. And first of all, we created an algorithm that is very close to the ones that the algorithm of companies are based on. And I call this nearest algorithm because this is basically about choosing the nearest possible available taxi around the request. So this will be the one that, for example, minimizes the waiting time for users. And then, just as a baseline, we try to create a totally random assignment, because if we want to look at the fairness in the system, we assume that a totally random assignment would be really fair. So maybe the nearest algorithm will create some inequalities, but the totally random one would not. And then, to address the problem of inequalities, we propose a third algorithm that is not only taking the distance into account, but chooses the taxi that has earned the least so far inside a certain circle around the request. So we keep track of the incomes of our drivers in our simulations. And that should be the algorithm that is going to try to equalize the income inequalities. We also have to set up many other parameters apart from this matching algorithm. So first of all, we have to know how many taxis we have in our simulated city. And we introduce the notion of taxi density here. I think it is a bit physicist-like metric. It's not very convenient. It measures the average distance between taxis, and then we can use the same metrics for different city sizes. It doesn't matter. Here you can see a city where the taxi density is very low, so there are basically only a few taxis, and you can see a dense city. And here you can see that a dense city means a small distance between the vehicles. Then we also have to set how many passengers there are in this system. Of course, a city where, for example, we double the number of taxis and double the number of passengers should just resemble the original one. So we do not use the passenger count, but we somehow kind of measure the fraction between the passengers and the taxis. I don't think it's worth going into the detail here, but it's kind of a fraction of two distances. Then, of course, the passengers are not equally distributed throughout a city. So, for example, if we have Beijing, which is the example on the right side, then we can see that in the inside, so in the inner city, there are much more requests than, for example, in the suburbs. We try to recreate this particular request distribution by using the artificial one on the left side, but we also can input many other geometric options into the system. The results I'm going to present are from this particular inner city one, but we also try to simulate, for example, the effect of an airport. What we have to see here that, of course, it's not real data, but we want to get as close to a realistic scenario as it is possible while keeping the parameters very simple, while keeping control of the whole system. Our first question, now that we've set the number of taxis, the number of passengers, the distribution of the passengers, we've defined the algorithms that pair the passengers to the taxis, is whether our system is capable of serving everyone. Because, of course, this is very crucial. So here, the figure shows that we're running the simulation, we reach a certain equilibrium, and as we add more and more passengers to the system, that goes to the right-hand side, up until a certain point, all algorithms serve everyone. They pick up everyone, they drop off everyone. But all three curves that represent the three algorithms break down at a certain point. So if we add more and more passengers, then there will be people who cannot be served anymore. And first, the random algorithm breaks down because it's not well optimized, of course. And it might be that we send someone from the other side of the city for one passenger. And the blue curve, that represents the very optimal algorithm, that is the nearest algorithm. That is a good system, for example, for a company. And we can see that is the one that performs best according to this metric. And which is very important, that the poorest algorithm, that is our slight modification for taking the workers' interests into account, just performs slightly worse than the nearest one. So we reach a saturation point in all three cases. Now, let's have a look at the incomes. What happens to the incomes as we add more and more passengers compared to the taxis into the system? Up until the same saturation point and before, we see that the driver's average income increases. Of course, if we reach this saturation, then the income also saturates, so drivers are working all the time and cannot earn anymore. We also see here that the random algorithm performs worst and that this optimal algorithm, that is the nearest one, performs best. And the poorest is somewhere in between. What is really important, though, that this was the average income of the drivers. And we are interested in the differences between the individual drivers. So, first of all, we try to measure inequality by measuring the variance in the driver income distribution. That is sort of measuring how far drivers are from the average. And we can see that there's a certain parameter range that is in the inset, that this kind of inequality goes very high for the nearest algorithm. And meanwhile, if we introduce this small correction, the orange curve goes almost to zero. That means that, that we can tackle this inequality by introducing this small modification, and this modification leads to even better outcomes for the drivers than, for example, a random assignment. We introduce another measure for inequality that looks slightly more complicated, but it also captures how unequal the incomes are distributed amongst drivers. And here we also see that as we add more and more passengers to the system, it becomes more and more fair. But if there's a low density of requests, which can basically happen in a real scenario as well, for example, during the night, then the optimized algorithm is very unequal. And the poorest algorithm outperforms the other two by far in this respect. So these figures were in a system where the number of taxis has been kept constant. But what if we fix the ratio between passengers and taxis, and we try to explore how these inequalities change with the taxi numbers? Here we see that as we move to denser and denser cities, the inequality grows according to this variance metric, as well as according to the other Atkinson index metric as well. Here, our algorithm is also capable of mitigating these differences. So, all in all, we've created a simulation system that has various input and output possibilities, and we've seen that in certain parameter ranges, the inequality grows in the system as the number of requests decreases, or as cities get denser and denser, but with constant taxi-to-passenger ratio. We've also seen that the proposed poorest strategy helps, and this help is without a very big loss, for example, in the total income in the system. And it is also very important to note that as opposed to Ancha's work, where these biases were reflecting, for example, offline biases, or as opposed to much research in the social sciences, where, for example, the driver's rating influences in kind of a negative spiral the driver's incomes, our drivers are totally equal in skills and totally equal in working time as well. So the inequality in their incomes arises just from the natural geometric distribution of the requests and is only introduced by the algorithm into the system. With such a system, we can test the effect of different geometries. We could also have real data input, which we plan in the future to include. And I wanted to add one more slide to explain why this all is data science, because it's not real data, right? So we have an artificial data source, but it generates such amount of data that we have to use very similar techniques that are used, for example, for real data handling. We could also use real data as an input to the generation of such a simulation, or real data to compare the outcomes of such a simulation. And I believe that these systems could be very useful for testing different policies, or for testing companies' strategies to make them more transparent. Thank you very much for your attention, and I'm awaiting the questions.
Questions? More questions? There's a question.
How was the pricing formula created, or is this whole result changing if you change the pricing?
We used the linear pricing, which took, for example, fuel consumption or a mile-based fee into account. We tried to make it similar to that of Budapest taxes. So what you've seen in the picture were real Hungarian forints, for example.
More questions? There's one over there. Okay, thanks.
So do you think that the income inequality in the results could be mitigated if, so maybe a driver gets a new income every day, so if he gets a different random position in the distribution, then the, I don't know if my question is
yes,
clear. So
I think it's clear, and so those simulations are currently running on the servers of ELTE, where we test that if we reset the driver's income or if we reset their position, whether that affects this kind of accumulating gap in their incomes. But I cannot answer right now.
More, where's more question? There's one in the middle and in the back, but the back one I can see.
Hi. Hi, I have a question regarding is this simulation taking account different services that they can provide? For example, luxury services of taxis against normal services. My other question is related to, there is a way to promote the taxis with poorest income? Like the system may suggest, hey, you should go to this area and try to keep balancing incomes of these taxis just to moving around areas. That's it.
So for the first part, I think that those systems would be just the superposition of, for example, 2 or 3 exemplars from our systems. There would be, because these systems are non-interacting. So if there are luxurious taxis in a city and if there are some basic taxis in the city, I think they can just be put on top of each other because they are different categories. And sorry, could you please tell the second part of the question again?
I think he said that if you... Okay, whatever, he got the mic.
Yeah, is more regarding to like how to suggest the workers of the app, the taxi drivers, like to move around the zones to kind of balancing the incomes of the taxis to avoid some sort of inequality. For example, like if an area is too crowded and the requests are low, like they suggest to move to other area, etc., etc.
I think they are trying, so for example, Uber is trying to control that through the pricing, because not every ride has the same price, and then this pricing motivates the drivers in kind of a game theory fashion to serve the more frequented areas. Yes, there are different strategies, and ours is only one possible way, but it is automated and algorithmic, so it might be more deterministic than, for example, just motivating the drivers by pricing or by any other means.
And we had to... You had as well? No, she won. Okay.
Hello, good evening. This is in reference to what we had experienced in Southeast Asia with Uber. So I was able to talk to some Uber drivers there, and they, in their system, there was, in relation to what you had mentioned earlier, there was some kind of incentive system provided by Uber to them, in terms of that would motivate them to go for to achieve certain number of hours in a week or in a day, and to increase income. So have you ever considered incorporating that in your study?
Not yet, because so I think our main interest lies in the gaps that only geometric constraints or algorithmic constraints introduce. And of course, the parameter space for exploration is huge. And maybe this should be just regarded as a possible framework for testing and exploring such algorithms. And then, so when we'll publish, I think we'll publish the code, and everybody is going to be free to explore.
Great. We have time for one last question, a short one. Okay, I threatened you enough. So then, thank you very much. It was really, really interesting. So. We have our last speaker before the break, and she's Evelin Meszaros, please. She studied survey statistics at the Eötvös-Loránd University, where she learned basic coding and data analysis, which is a pleasure for me because I think I was teaching her for Python, so it's amazing to know that she actually became a text mining expert, and she works at Clementine as an analyst, and she's gonna show us some showcases of NLP projects in Hungarian, as far as I'm sure. Yes. So, go ahead.
So it's a great pleasure to be here, and in my presentation I would like to talk about text mining projects and challenges I had in my job experience of only 2 years, but I think it would be very interesting. Oh, sorry. So, in the first part of my presentation, I would like to talk about a bit about the theoretical background of text mining, and in the second part of my presentation, I will show you some open source possibilities in connection with text mining Hungarian language sources. And in the end, I would like to show you a possibility how we can complete the deficiencies of open source programming languages in Hungarian with a commercial software. So a bit about the theoretical background, because the steps of preparing the text for the data analysis is a very important step of text mining. The first step is tokenization, which is a step when we break the text into single entities, and we can define the tokens we want to analyze. One token can be of one or more words, for example, but it depends on the project. And the second step of text mining is the normalization of the text, which is a key step in the preparing, because in this case the structure of the analyzed language matters a lot. For example, we can see two methods for normalizing the text. The stemming is a more mechanical way of removing the suffixes from the text, and the lemmatization is a bit more complicated method for do this. But I think preparing the text can determine the result of my analysis, and it is very important to be aware the nature of our analyzed language. And the last step of preparing the text is removing stop words. Stop words are words which are irrelevant in connection with our project. It could be an article, an adverb, and so on, but it is very important that built-in stop words list in open source language, programming languages should be changed in connection with the project. One basic definition is the corpus. There are a huge amount of definitions in connection with corpus, but I think the best is that corpus is a collection of text stored in electronic forms. And in this slide we can see a sample of corpus viewed in RStudio. And the other most important feature is documenter matrix, because when we want to analyze data, analyze text, we have to transform text to data to apply statistical methods for the analysis. And in this slide we can see a matrix in which the column names refers to the tokens, and the row names refers to the items of a corpus, and the cells refers to the frequency of an item of a token presented in the item of a corpus. And it's only the one method for doing the transformation between text and data, but because the lack of time, I don't have possibility to show you other methods, but it can be a very difficult to determine the method in connection with the project. And let's go on with the practical part of my presentation. In the last 2 years, I had an academic and a business experience also, because in 2016, I started my training at the Hungarian Academy of Science in the Institute for Political Science in the Comparative Agendas project, which is an international project for investigating trends in policymaking, and the method for comparing the results between countries is the classifying, because in this project there is a code book, there is an international code book of more than 20 major topics and more than 200 subtopics to be able to compare the results between countries. And when I started to work in the project, my first exercise was making a media database from Népszabadság. Népszabadság was a daily newspaper in Hungary until the summer of 2016, and fortunately one website published the whole content of Népszabadság, and we decided to make a database from the articles of the main pages of Népszabadság to analyze in the project of the CAP. And our method was collect the data with the web scraping technique in Python, and then after the database had been created, we wanted to analyze the text in R with the R text tools package. Later, I would like to talk about more about this package, but this package is a package which contains 9 different algorithms in connection with supervised learning techniques, and it's a great feature for doing this analysis. The automation of collecting all of the articles in Népszabadság took 2 days, so it was a bit difficult, but in this process the language does not matter. And after we had the database, we decided to make another database in connection with media, with the Magyar Nemzet, which is also a Hungarian newspaper, but the method was different because we wanted to apply optical character recognition for the main pages, and in this method we had difficulties in connection with the Hungarian language because we had a few possibilities to do this optical character recognition in Hungarian. In connection with open source programming languages, the TICA package of Python was the best, but commercial software called Abby Fine Reader was the best solution for doing this transformation. The main difficulties were that the software did not detect well the breakings in the text, and the presence of the white spaces were also present. So finally, we experienced that with the web scraping technique of Python, we did a few. We had few mistakes in connection with the Hungarian language, and the main disadvantage of the automation was that we have to correct manually the database because we had main pages of the Népszabadság, but we wanted to have articles from the main pages. And in connection with Magyar Nemzet, the situation was worse because we had another softwares. And then we went on with the data analysis. And as I mentioned, we applied the supervised learning algorithms from the RTEX tools package. And the cause of it was that we saw many publications in which they saw good results in English texts. But we experienced that in Hungarian texts, the results were bad because we wanted to compare the algorithms amongst three measures: the precision, the recall, and the F-score. These precisions refers to the rate of the correctly classified items in a corpus, but we decided to compare the algorithms among precision because it refers to the rate of the correctly classified items of a corpus in a test set. So we experienced that less cluster made better results, but it does not depend on the structure of the language. And finally, we only could reach only 70% of precision in connection with Hungarian texts. And I think the main cause of this phenomenon is the nature of the Hungarian language, because the agglutinative language with the free word order, we could not train the algorithm efficiently. And when I started to work at Clementine, I experienced the business experience in this natural language processing, and we decided to make a call center assistant who can switch the client to the appropriate assistant in the banking sphere. And the difficulty was that we had not a corpus. So we had to generate a corpus which is relevant to this exercise, but preparing the corpus was different from the academic experience because we had a commercial software called IBM SPSS Modeler, which has a very good module called ClemText, which is a module especially for the lemmatization of Hungarian texts. And we started to preparing the corpus among these techniques. The method of the data analysis was that after we had a corpus, we applied different classification methods for the corpus, and the main disadvantage of this application was that we couldn't decide how many clusters are there in the corpus. So we had to create and check manually the classification results in connection with our corpus, and the final solution was the clustering classification of more than 40 clusters. And the main difficulty of applying supervised learning methods in Hungarian, that one form of stamped and clean text can refer to two two topics, because if the stamped and clean text is transfer money, it can refer to an account information if we wanted to say that I wanted to transfer a larger amount of money. And if we want to transfer a large amount of money, actually, it is a request which had to be switched to a payment. So we applied Magyar Lánc, which is a morphological parser of the University of Szeged, and for the Hungarian language, it is the best solution for do this. And finally, I would like to summarize my presentation. So we had to be aware of the structure of the analyzed language, and our call center assistant called Hannak is a good hybrid solution of the open source programming languages and the commercial softwares, and we can see that the efficiency of the supervised learning methods can be improved by manually created rules by professionals, and these rules are grammatical rules, and with this solution we could reach more than 90% of precision in connection with this topic. And the character encoding is also a very important keyword in this text mining. So thank you for your attention.
Questions? More questions? I do have a question. What would you recommend for someone who wants to start with text mining? Like, how should they start? Like
in Hungarian text or
any way?
I think with Python we can do text mining in a very efficient way, but the lack of the corpus and in different small languages is a big constraint of doing text mining. So, but I think with Python we had do this. And for example, in this software in Modeler, we can integrate the Python logic, and we can do this in a very efficient way. So.
Thank you. More questions?
So
Okay.
how far do you think we are to be able to do something like this completely with free source languages? Like, you said that you use the hybrid method with free source languages and commercial softwares. So do you think it's ever going to be possible to do this analysis just only in Python or Python and R?
I think it's possible, but for example, in the business, I think we have to do more precise models, and I experienced that in open source programming languages, the efficiencies of the preparing the text is the biggest constraint.
Thank you very much, Evelin. And yeah, thank you very much for Evelin again.
Okay, so now we'll keep a little break, but don't spend too much time outside, because our next presentation will be by Goblos-Szabo Júlia, and it will be more from a market-oriented perspective, because its title is When Data Science Meets Product Development. So, see you in 10 minutes. So, welcome back, everyone. And I would like to introduce you our new presenter, our next presenter, Julianna Goblos-Szabo, who is a software engineer at the Skyscanner. And also, she has more than 10 years of experience as a consultant, with which, so she worked both as engineer and also as a data scientist. So the intersection of these two is what she will talk about. And it's important to mention that she's also one of the organizers of the Art Ladies in Budapest. So, your stage is yours.
Hi, everyone. First of all, I would like to say thank you to all the amazing ladies who let me cut in front of the line at the bathroom. This was a very unusual tech conference experience at the ladies' bathroom, so thanks for all your understanding. So today I decided not to bring a use case and a deep dive into one of our projects, but rather describe my experience as a data-related person working in a product team, in a product developer team. This was pretty unusual for me, and I learned a lot in the past 2 years at Skyscanner, so this is what I would like to share with you today. And first of all, a little bit about me. So, hi, I'm Júlia, and it's very scary to say out loud, but I've been in this field for 10 years today. And first, I started as an intern in Staki, which is a research institute here in Budapest. And back then, it wasn't even called data science, it was called data mining. I'm not even sure if anyone remembers this term anymore. But I spent 4 years here, and I'm still very grateful for this time. This is when I learned programming after studying mathematics and really hating programming at the university. So this was really fun and life-changing. But after a while, I fall more in love with programming, so I switched from the academic career and I joined Prezi, where I did a completely different thing. I was in the data platform team, so I didn't really work with data, but we were enabling the company to do analysis and other cool stuff with data. So that was a very different sort of data experience, but very useful, and I recommend anyone to just look into this territory as well, because that can be also very interesting and useful. And then I realized that I would like to work more with data. So I joined another company, SSP, and I was a data engineer, which is a very vague job title. But what I actually did was working with all sorts of data integration, looking at data sets that we got from our business partners. I cleaned it, and I was responsible what sort of quality data goes into production. So finally, I could really make my hands dirty with data. So this was more what I wanted at that point. But then I joined Skyscanner, where at the beginning I was an engineer. I would call myself data engineer here again, but it was really different. So here we built products that were fueled with data, so powered by some sort of machine learning algorithm or some sort of data processing. And recently, in the last 6 months, I've been transitioning, and I would describe myself more like a product analyst. And you will see what I learned during this phase. And before we dive in, before I share my big learnings, I just want to set some definitions straight. This is how I will refer to these things. You may have different definitions, and that's fine. I just want to make sure that we all understand the same things when I say data science or machine learning in this next 25 minutes. So when I say data science, I will mean something like a task, a work that produces insights. So for example, a data analyst, a product analyst, they produce insights that a stakeholder can look at and decide. And that's what I will refer as data science. The other term that I will use a lot is machine learning. For me, machine learning produces prediction. So if you have a cool algorithm that predicts fraud, that's machine learning, according to my definition. And then there is a third term that I will try to avoid in this presentation. It's artificial intelligence. It's a really big buzzword, so like everyone has different ideas what that may mean. But I think artificial intelligence is something that produces an action. So for example, if you have a chatbot or you have a robot, that might be, then you can refer to it as artificial intelligence. And as I was creating this slide, I was looking around for these definitions, and I found something very cool, this thing called AI effect, which claims that basically AI is anything that has not been done yet. Because if something is doable, is achievable, then people don't feel that it classifies as AI, because that sounds so mystical. So yeah, it's just food for thought. Okay, and now we arrive to the main part of my talk. I brought you a couple of common misconceptions that we have faced at Skyscanner when we started to bring in data science to product teams. And I will try to give some advice how to get around them or how to avoid them. So the first thing when you go to a product manager or a designer who have never worked with machine learning or data, then they will be probably scared. They may claim that, machine learning takes away the control from me because it's just a black box. I don't really know what's going on in the product, and I want to be in control. I am responsible for this product. I want to know what gets in front of the user. And also the designer may claim that I cannot really design this thing because I don't know what text your algorithm will produce. I don't know how it will look. I don't want my name to be associated with something that I can't control. And just to be fair, these are very valid concerns. So this is something that you have to think about. And yeah, in this case, as a data scientist, try to memorize the little icons because they will come back on the next slides. So what can a data scientist do in this case? First of all, your job is to educate and evangelize. So for example, you can argue that, yes, some models really act like a black box, for example, a neural network, but there are some others that are more explainable. So maybe you can convince your teammates that there are models that are pretty safe to use because they won't take that much control away from them, or at least they can reason about what happens in the model. And also, let's not forget that you have to listen to those concerns because they are probably valid concerns brought in by different field of expertise, and you probably just haven't thought about those. So usually these concerns are really valid. But something that you can do with these concerns is translate them to requirements. And only if you check all these little boxes, only then can you have a well-working relationship with these people, a very healthy and balanced team together. And I also brought you an example. So my team works on the Skyscanner mobile app. And you probably know that in Skyscanner you can search for example, for flight tickets. So you enter where you want to travel, when you want to travel, and then you see all the flights that are going on that certain day, and also you can see the prices. And that's all nice, but teams came up with the idea that, we can do better. We are sitting on the top of lots of data. So for example, we can help the users with figuring out when there is a better flight. And the better flight can be a direct flight on another day. That is, and we can suggest them that, hey, if you just leave a day later, then you have a much more convenient flight, 3 hours shorter. Or we can also suggest you that if you leave a day later, then you can save lots of money. And these are very useful tips, but The problem is that, for example, here you don't see any more results because all you see is these tips. And this is maybe not what the user wants. So, and by the way, these little things that are not the results, we called widgets. And we had this wonderful idea that, okay, we can use machine learning to learn iteratively in a real-time fashion for which sort of search, what widget we should show and in which order, and we can combine these layouts and figure out what's the best. And we were super enthusiastic about this. We spent lots of time on it. It was one of the most exciting projects. And then once we heard back from support that they were super frustrated with this because if we introduce some sort of randomness here by iteratively sometimes allocating random layouts, and then after a while having some pretty deterministic ones, they may not be able to help the users who complain that they saw something or they did not see something that they expected because it's not reproducible. So this is a valid concern. Someone couldn't do their job if we do it this way. So we had to translate it into requirement. And for example, here we could track what sort of layout the user saw. So even if the support agent couldn't reproduce it, they could still look it up, what the user saw. Okay, so next misconception. Once you convinced everyone, all your designers and product people love machine learning, they may think that, okay, that's the solution for everything. And everyone is super excited to start another new cool machine learning project. And that might not be ideal either. And in this case, the data scientist's responsibility is to think that is really a machine learning really required for this particular business problem? Because it might not be the right answer. So first of all, before jumping on any cool new article that you read on Medium, you should always start with some analysis. Look at the data, look for patterns that are noticeable by hand or by the eye, and with all this, implement a baseline method. So no machine learning first, nothing, because it brings so much additional complexity, especially in deployment and in resources. So always try something very simple, easy to put in production, and only then. It can happen that at this point you have such an improvement that it's okay to stop and move on to the next very important problem. But if not, then you may still work on a machine learning solution, but bear in mind that this may have a really big additional cost. So you have to develop the algorithm. You have to prove in an offline evaluation that it's working well, and then you have to work with the engineering team to deploy it. And then probably you have an A/B test, which is either successful or not, and by then at least 2 months passed. So yeah, it has lots of costs, so always keep in mind if it's worth it or not. The third misconception is that as a data scientist, it's a very common pitfall that you are convinced that all you need is a good machine learning model. So you develop the best machine learning model in the world, and then you will change the product and money will just be poured on the company. And yeah, it's not the case. So something that really matters is design. So for example, again, the mobile app, and this is another view of the result page. When I joined Skyscanner, this was almost 2 years ago, that's when we were experimenting with this recommended for you widget. The idea was that we developed an amazing ranking function that could tell what are the best itineraries in the list. So what are the best tickets that you can buy? And so by default, it's the cheapest, usually what's on the top, but that might be super slow. So some reasonable trade-off has to be made. And we showed this layout to the users, and they were a bit skeptical that, how do you know what is best for me? So one thing that you have to know that in our app, you don't have to sign in. So the user has like a reasonable doubt that how would you know who I am and what I like? So this messaging wasn't really good. So, okay, we decided that we will change it. And we renamed it to Best Flights. And then again, we did a user test, and then users were hesitant to tap on it because it must be an ad, and I just don't want to tap on ads. It can't be that good because someone paid for this. And it wasn't an ad. It was really something that was produced by an algorithm which looked at years of, or months of data, or even a year of data, trying to figure out what sort of itineraries user liked. But still, if you cannot really present it in a good way to the users, in a way that they believe what's there, then it doesn't really matter. So one thing that I learned here is that I had to work with our designer pretty closely and, for example, explain to him that, okay, is it okay if we write recommended for you or not? Because it wasn't a personalized algorithm. So it just didn't really make sense to put it there. Okay, next pitfall. I already touched the problem of deploying an algorithm. And yeah, this is luckily something that we didn't commit because I was there to stand between data science and engineering, but I've seen in other teams that the data scientist went away for a month, developed a model, and then after a while, she just basically threw the model over the fence to engineering and told them that, hey, put it in production. And the problem was that she developed a model in Python, and the team worked with Java, and they were like, okay, I cannot really deploy it because those are not compatible. So one learning is that you have to iterate from early on, or at least talk to each other, maybe set some standards that, okay, how different technologies will work together. And yeah, this is my last 6 months, so this is currently my favorite topic. This is also happening in Skyscanner, that we are using lots of self-service product analytics tools like Mixpanel, Google Analytics, and so on. And we didn't really have product analysts, so dedicated people who just analyze data. But there are people who have questions like, how many active users we have? And okay, what if I want to change the active definition? Or what if I have a special way to track users? And you may not be able to do this with this self-service analytics tool. Or like a much more broad questions that, is my product growing in a healthy rate? It's really hard to click together a funnel or something that really answers this. Or, for example, which features are working well? Okay, this is something that you might be able to approach, but there are a lot of pitfalls here that you should avoid. So how can a data scientist help here? Well, first of all, the data scientist's responsibility is to come up with the frameworks that maybe the whole organization will use for analytics. For example, A/B testing. Someone came up with this nice framework, and everyone can use it, even with this self-serve tools like Mixpanel, but someone had to set the groundwork for the framework. And then you have to implement metrics. So whatever you came up within your framework, you should work on it, or you should team up with engineers to implement it, but you should be close to them. And once you have the metrics, you should explain what they tell us, what story they tell about the users or the product. Without that, a metric just is a number. It doesn't really make any sense to have a number without any interpretation. And of course, if needed, scale this out to the whole organization. That's when you will have the real impact. And around this topic, it might seem that if you're a data analyst, then basically you can just go alone and After you figured out these metrics, you can just build a dashboard easily alone. But that's not true. Again, for example, you need to collaborate with lots of people. So first of all, just to know what's in the data that's coming out from the product, in our case from the mobile app, you have to work closely with the developers, because you might suspect that the event that's called search is what you need, but then it turns out that no, is it? Okay. Oh, it's back, okay. But it can happen that it's actually what you need is flight search, and you just do all your analysis and it turns out that you used the wrong event. And then you probably need some help from a data engineer who can advise you with some like hardcore data heavy lifting and help with all the tooling that's out there or in the organization and with all these things. And let's not forget about the dashboard user. We worked on such a project a couple of months ago, and this was the biggest learning, that you basically have to act like a product designer and a UX researcher and figure out how the end user will really use the product and how it's the most convenient for them, because something that might make sense to you, putting a big red button, it may not work for them. So just to sum it up, so how can you avoid most of these pitfalls? Well, I think that the best thing that you can do is that you as a data scientist work closely together with as many disciplines as possible, with design, product, engineering, and you don't have to talk every day, but pretty regularly, and whenever something comes up, you have to be open to listen to their disciplines, to their concerns. So I recommend not to sit in your ivory tower alone as a data scientist. Just go out and talk to other people. And thank you.
Thank you for the nice presentation. Does anyone have any questions, comments?
If nobody has, I have a lot. So thank you very much. It was really good. So what you said, that you are on the part of like these cross-functional teams, so, or you prefer to have a data science team which work with other people?
So in Skyscanner, we have mainly cross-functional teams. We have a couple of functions that don't work like that. For example, the data platform has it's a platform team, so they mainly have just engineers. But the product teams who work on the user-facing product, they have usually a product manager, a designer, sometimes, if needed, a data scientist, and like 5 or 6 engineers. So they are pretty multidisciplinary teams. And I prefer those teams. I think it's really cool to work with a wide variety of people and learn from them.
Anyone else? Right, so thank you again. And now I would like to ask every panelist to the stage. Eszter. So, thank you really very much that you accepted our invitation for this panel about the future of data science from the perspectives of women. And let me introduce you, our panelists, one by one. So, first of all, Beata Nagy, who is a professor at the Corvinus University at the Institute of Sociology and Social Policy, and also the co-director of the Gender and Cultural Center. I would like also to mention that Beata published a book about the lack of female students in IT and technology, so she's really an expert of the field. And also, of course, published several articles in very prestigious journals. Actually, as I know right now, so currently you are working on a project between a Hungarian and Japanese comparative project, yes, about women economics or women economics. Yes. Yeah. Right. So thank you. Then Melinda Lontai from SAP. So Melinda graduated at the Vienna University of Economics and Business Administration with a major of information management. And right after graduation, she joined the Global Risk Management Solution team at PricewaterhouseCoopers. And it's interesting because, as I realized, during your job, you just realized that, that maybe some information technology diploma would be also useful for you. So you started and finished the bachelor diploma about computer engineering in Budapest, right? And yeah, she currently works at SAP as a product owner, which you already know what is it from the previous presentation. Okay, so Anna Vancho. She's a senior analyst at Ethical Labs and also a PhD student in sociology, also at Corvinus University. And her main research areas are representations of campaigns and public issues using big data approaches and text analytics and also content analysis. And finally, Eszter Windhager-Pokol, who is one of the 2 Hungarian female head of data science, as we know, and she has more than 10 years of experience supporting data-driven decision-making as a consultant, and also developing machine learning techniques for IT security, and she is the organizer of the Our Ladies Budapest. So, thank you that you accepted our invitation. And so, first of all, let me just have a question for Beata, because you really have some current researches on this field. That what is the ratio of women in data science and other related fields?
Okay. Thank you. Thank you for. Yeah, thank you for the invitation. So I don't know the data all the time, so I had to refresh the data, and I checked the US data because they have they publish lots of new figures, because it turned out that they need in a very short time 1.4 million people for computing. So it turned out that women are present there in 26%. So 26% of people working in computing occupations are women. And what surprised me very much that the number is decreasing. So my expectation was that more and more women enter the higher education. We know that everywhere there are more women, and it might be true for the data scientists, for computation, but it is not the case. So it was a huge surprise for me, so I started to go behind the data, and I checked also the European Union data. The European Union cannot be very proud of itself either. So we cannot see a huge increase. Just to leave the worst result, which is Hungary. So nowadays in Hungary, if we check the higher education, particularly the PhD programs in computing, we can see 6% of students are women, which is decreasing again. So it is so strange that there is a demand for computer scientists, and women cannot catch up with men in this game somehow.
Thank you. And maybe you have some information about the workplaces. I mean, if just women. So I mean, what are the typical positions women hold in this sector?
So there is a segregation, like everywhere. So women are not in the most important position. So there is a vertical segregation in computing as well. And if we look at the statistics, we can focus on computing, but very often we focus on STEM fields, science, technology, engineering, and mathematics, which is a much wider category. And if we look at STEM, we can see many, many women there. So it is increasing. But if we look at the narrow category, then we can see that there is a high segregation, and women have difficulties to enter the field, and once they enter the field, they very often leave the field. But maybe we can come back to that later. So why women leave computing?
Absolutely. Eszter, do you have the same experience? I mean, that you have really a lot of experience in data science, and how would you describe those positions that women typically hold? Or is there any difference between men and women and the positions they can take?
Yes, I don't know the exact numbers, but my experience is that women usually tend to have lower positions. And I think there are two reasons behind this phenomenon. The first one is that some women decide to focus more on the family, so they don't really want to build careers, but others who wanted to build careers, they don't take risks, so they take less risk than men. They don't change the workplace if they are not promoted. They stay where they are, so that's why employees promote men, because they would leave the job otherwise. So I think women should take more risk.
And Melinda, have you ever felt like really gender issues in your working life? I mean, like issues that are typically attached to women or men, based on even positions or promotions, or?
No, I haven't. I have to admit that I haven't experienced any issues. So at SAP, diversity and inclusion are very important topics, key topics in the company strategy. And not only on a high level, so not only on corporate slideshows or stuff like that, but in the real life, in reality as well. So there are a lot of trainings, there are a lot of events that aim to raise the awareness of the colleagues and also to change the mindset of especially of the male colleagues. So probably this is why I haven't received any issues. I haven't experienced any issues in this field. So of course, I don't know the salaries of my male colleagues, so I cannot compare this. But with promotions, things like that, no.
Just great to hear good news like that.
Yes.
And Anna, what are your experiences about this topic?
Yeah, it's a little bit different because I work for a small company, which was a startup, and if I remember, I was the 5th person who was an employee in this company, and now it's like 40. And since it's very small, these kind of issues were not mentioned, because the most important thing was that we have more people and how to include them into the project, how to make them feel comfortable in the workplace. But when I started to think about one thing is that in the daily routine, we have a small office, and the cleaning stuff is basically done by women in the workplace. So like clean the coffee machine and those kind of things. And also just really, really in some cases, we were not taken that seriously than when other men colleagues complained about something. But in general, we do not really experience these kind of things. I think it's really because there are a lot of youth, so it's more, if there are difficulties or differences between employees in the company, is more about because of the life stages we have, like the students and the non-students. But it's not a problem in general.
I started to think about what Beata already mentioned, that I mean the roots of these differentiations start earlier. So can you just tell us that, I mean, what kind of diplomas do you have? Because it's really interesting. I mean, data science is a really diverse field. I mean, you can go there with a lot of different knowledge. So what, I mean, I've already said that you are a graduate student at the Corvinus University of Sociology, and your master degree is also sociology?
Yeah, into sociology.
So I am not a data scientist, I have to admit. I just make use of the results of the data science in our applications. So this is why I can live with my business degree and with my engineering degree. So this is why I don't need a data scientist.
But your engineer degree is also important for you to understand the process.
Absolutely. And of course, during my business studies, we learned a lot of statistics, which I didn't like very much at the time, and I didn't understand why do I need that. But now I make use of that a lot.
I have a master's degree in applied mathematics, and at that time there was no such data science, but there were some smaller courses on data mining where we studied the basics of it.
Yeah, so I don't come from this field, so I'm a sociologist and economist by profession.
The reason I asked it because I just wanted to ask about your experience from university, from graduate school, or even from bachelor school. That how did you realize? I mean, what was the composition of your classmates? And especially interesting that it's because basically there's some. So I have some insights that maybe for the tougher topics like mathematics and computer engineering and other different classes like that, I mean, there are mainly men who chose those fields. But maybe sociology is a little bit more soft skill needed and so on, so maybe more women chooses those faculties. How do you see that?
Yeah, you are absolutely right. So we experienced that there are feminized fields, and sociology is very much dominated by women, and mathematics is dominated by men, which, it might be problem to some extent. Of course, it is not good if jobs or fields are segregated. But the other point is that jobs connected to quantitative sciences have a much higher prestige in society. So the main issue is, I think, that is not that women learn more in human sciences and sociology. The problem is that these fields are underevaluated by society. So it would be nice if not only women could enter the mathematics and engineering, but also humanities and social sciences, pedagogy and social work, etc., which are filled by women, could have a higher prestige. So what we now really see that quantitative jobs have a much higher prestige, and they have more job opportunities and so on. And it is not just.
For me, it was a strange experience because there was a faculty of mathematics, and there the ratio of women was very low, so like 1 or 2 students per year. But I studied applied mathematics, which was almost the same. So very few differences between the two topics, mathematics and applied mathematics. Many courses we studied together. But on applied mathematics, half of the students were women.
So when I studied business administration, either in Budapest or Vienna, the ratio was about 50-50. But now when I am sitting in a meeting, it's in development, so software development. So when I sit in a meeting, it's usually from 10 people, it is 8 guys and 2 women. So.
Okay, I'm a sociologist, so we have some sort of same experiences, but just what you said about applied and like the more theoretical mathematics, it's something like this in sociology, I think, as well. Like there are hierarchies. Like there are students or professors who deal with theoretical, like very high intellectual theoretical, I don't know what, and it's in the highest prestigious, and then maybe the quantitative, and then if you I use in many cases discourse analysis, which is very qualitative and hardly understand what you do and hard to define what you do, and then this is the lowest part of this one because people don't understand it. Like it's not because it's so complicated, just don't know what does it mean. And I think that's what Beata said about this prestigious thing, that engineering, like it's very manly, it's very understandable, and Also in sociology, like who do quantitative work, it's again something very like manly kind of area. So it's very interesting, I think.
I also think that it's interesting, but the question is that what are the roots of these processes? I mean, what do you think that why women choose less those classes or even those faculties which are more quantitative and less qualitative?
I started because we had some research on that. So it is not because women are not good at mathematics, that's clear. And we already have the PISA data for competency mathematics. And it is clear that women are as good as men in mathematics. The difference is that women are less motivated to study mathematics, and they don't receive a positive feedback from the environment. And I think it is a catch-22, because they have less confidence, so they receive less positive feedbacks, and it goes further down. So by the end of the secondary school, when they choose, or even a bit earlier, when they choose specialization, they decide not to go into quantitative direction because everybody says that it is not your field. It is not good for women. You cannot make IT together with a family. It's better to limit your perspectives and so on. So they receive so many negative or social messages from the environment that they change their mind. And instead of mathematics or physics, they rather go into soft sciences. So we had this. We have learned this data from secondary schools, where students and teachers and even parents were asked. And later on, I continued in a higher educational institute. So I went to a university, and it was very much the same. The world is full with stereotypes, and they don't support women in these fields.
I have exactly the same experience. As you mentioned, I'm one of the organizers of the Our Ladies Budapest meetup group, and we talk a lot with the participants there. And they say that they don't dare to start learning coding, for example, because they think that they are not smart enough for that. So when we started to organize the Our Ladies Budapest meetup group, my 10-year-old daughter came with me. And when the ladies saw that a child is brave enough to start it, then they thought, okay, I might understand it as well. So they needed some support. So I think this supportive, friendly environment is very important for them.
So I don't know the reasons, but what I see is that I have a 9-year-old son, and he goes to a coding club after school, and there are 15 boys and no girls in the club. So probably this won't change in the near future. Maybe I will just come back to what someone from the audience mentioned at the end of the first presentation, that women tend to have less self-esteem. And if there is a job description with, let's say, 10 requirements, yes, I think it was, okay. So if there is a job description with like 10 requirements and a woman meets 8 and doesn't meet 2 of them, then she won't apply for this job. And if a man meets already 3, then he will apply. So what they do at SAP at the moment is that they reword and restructure the job descriptions so that women are also more motivated to apply for those jobs. Yeah, I still have them.
Yeah, you also already mentioned almost everything what I wanted to say, but I think it's all somehow this self-esteem also can be strengthened with experience. And as Beata mentioned, that women tend to keep the position, or keep the position, not taking risk. So you don't have so many experiences, for example, applying a job. And after a while, if you've already done 15 different kind of interviews and applications, then maybe you realize that, yeah, if you lack 2 skills, then who cares? You still have a chance to go to the next round. But this kind of lack of experience also can cause lower self-esteem.
And how do you see the future of data science? Not even in Hungary, I mean, even globally. So can you see positions which will just disappear in the future? Maybe new ones, new skills that will be needed for being a data scientist? And maybe, I mean, how you can see the position of women in these trends?
So maybe my opinion as a product owner. So I am product owner in terms of I try to understand the requirements of our customers, and I try to translate it into backlog items or development items for the developers. And I also contact the data analysts who will then provide us algorithms and tools that we can build into our applications, and we can make those tools available for the customers who are less experienced with data science. And what I think is that beside data science, it is very important to have experience or education in other areas. So for example, in my case, it is very important that I can understand the requirements of the business users so that I can understand the business processes, I can understand what they need.
So data science is a new field, and I'm pretty sure it will change a lot in the future, so new skills will needed. For example, 10 years ago, visual interface tools were very popular, so no coding skills were needed. And now open source programming languages are the more popular, so basically, if you are a data scientist, you have to write code. And we don't know what the future will bring, but I'm sure that we will need new skills as well.
So I liked Julci's last sentences because she started to speak about the teamwork, and you always have to work together with other people. And it means that not only different disciplines, but different approaches are very much needed for the development of the field. So I think women will be needed very much, as not only women, but ethnicity and age differences might be more and more important every field, because if you can build a diverse team, the performance will be better. So it is the business case. Everybody knows that. Everybody speaks about that. I don't know whether companies try or can meet the target to increase the diversity. I don't know how you see whether it has a future, but in the literature and in the numbers, we can see that it is better for companies. It is better for people, and women are there, so they are in the pool more or less. I don't know how you see whether we go into this direction or not.
So SAP definitely tries to go into that direction, because SAP also realized that profitability, innovation is much better in teams where there are together men and women, and not just men and women, diversity. If there is diversity in the team, then the results of the team are much better. So there are many things that SAP does for this. One thing is that I already mentioned is rewording of the job descriptions, but there are a lot of other things. For example, there are coding clubs for the children in elementary school, because they would like to encourage girls and boys, of course, as well, to try coding. And there are a lot of events at universities and high schools to bring coding closer to girls and boys as well. So there are a lot of things that SAP does in this field.
for me, it just seems logical that there are going to be more and more women in this field, since there are more and more, like the data, the number of data is growing exponentially. So there will be a need for more people to do this job. And then for me, it seems logical that not only women, but based on the color of the skin it doesn't matter, there will be a need for people who do this job. I think it's maybe more important at what part they will do. Like, if I remember well, when the whole computerization started, women was working on the computers, but mainly on the basic mathematical calculations, and men were the engineers who design all these kind of things, but women were there who did the hard job. So then my question is more about that, what's going to be the direction of data science, what women will do, because they will do a lot of things, but in which level?
One last question. That, as Orsi showed you, those who filled out our little survey, I mean, from the participants, I mean, more than half of the participants are junior on this field. So just, watching a girl who would like to be a data scientist, what would you suggest her? What to do? How to start it?
Okay, my idea, just look for someone who knows this field, or just start to look for the people who do it, and try to talk to someone who do it. And how does it look like? What is your daily routine? How you do it? How you started to do it? Because I think it's the best way to see how it works.
Maybe just start with learning the basics. So mathematics, statistics, so the basics.
Yes, I would say also to learn very hard.
In Our Ladies?
Our Ladies, yes, and online courses as well. And also if when she started to work, then if she is not appreciated, then change and find the best workplace for her.
Okay, so just to say something extra to what you already told us, I think networking is very important in these senses. So I'm sitting on the board of the Hungarian Women Association for Science or something similar. So sorry, it's too late already. So what they do is they offer summer camps for girls. And we can see that this network of young girls support each other. And they receive lots of training in computing, in mathematics, but also soft skills and how to go further and how to dream about a job. And I think it is very important to see the role models. So I would widen up the circle of opportunities, because if you see not only your parents' career path, but other people, and you can speak to somebody who is a data analyst at a company or a startup or somewhere, but at a good place, which might be important for you, it is very important. And just to go back to girls, they are very eager to learn from each other. They are very eager to support each other, and I think it is very important, and we should build on that small circles, and there are more and more opportunities. So I know that Orsi, you started this Python program for girls, no? Yeah, you are part of it, but there are Django girls, there are other small circles, and I think it is very important that not only women as individuals should find a solution, but in groups as a feminist issue might be as well.
Thank you very much. Is there any questions from the audience you'd like to ask from our panelists? Yes. Could you just pass
Thank you. So I have a question to Beata. You mentioned that there is like a declining trend in the female participation in data science and programming related jobs. Do you have any hypothesis behind that? Like, why is it declining?
I cannot say you an exact explanation why it started to decrease. But there is a very strong chilly climate in classroom. And university in the US started a new program and they changed the curriculum in computing because they had a new rector and she realized that women are missing from university. So she changed the curriculum and they started to make a mixture of technical subjects and social sciences. And it turned out immediately that it is more attractive for women because women are more encouraged to go there and the proportion of women at these universities started to increase. So it depends very much on universities. So when I investigated a university in Hungary, I saw that everybody thinks so stereotypically. They don't take women seriously. So it is not a positive message for women. Yeah,
thank you. A last question, maybe a short question. Thank you.
It's actually not a question, it's a comment again. I am a comment girl here. So from this last thing, I should tell something. One of my leaders, when he hired me, then he thought to analyze data and find things which could be done better and so on. But if I find something and when I should be in conflict with others, in order to get the things better, he helps me because he should protect me. And then I felt like he underestimates me because I can stand for myself, I can stand for my results and so on. So these are also just stereotypes. I wanted to tell that. Men are so kind, but we can protect ourselves. So.
These were nice final words, I think. So thank you again for our panelists.
Don't worry, in 5 minutes you can eat. No, less than 5 minutes, don't worry.
Yeah, so we would like to thank you again for our fantastic speakers and for our fantastic panelists. Let's just clap them for a final time. And thank you again for our fantastic sponsors, SAP, BlackRock, and Starshema, and also, of course, for Central European University.
And we have a special thank you announcement because this would never, ever happen if we don't have an amazing person at the Department of Network and Data Science, Olga Peredi. Where is she? Can you, Olga, come here to the stage, please? We have a little surprise for you. Because it would ever, never, never, never happen if she doesn't help us. Thank you, Olga, so much. One more last thing.
Yeah, the last thing is that if you haven't done it yet, please like our Facebook page, like Women in Data Science Budapest. It's a different Facebook page than the conference page, okay? So this is the host of the conference. And why we ask you to do this is that we really would like to make it as a little community. I mean, even in the panel discussion, it was, several panelists mentioned that networking and mentoring are really the most important things to get ahead in your career. So we would like to ask all of you to post there, okay? So post about any interesting things like conferences or any interesting positions or data science related questions. So anything that is in your head, and try to build a little community on this page. We would be really happy if it would work.
Yeah, we will also share there like cool scholarships or how to start with coding or whatever you want, or more hardcore, like more deep stuff. So please join there. It's gonna be, I think, a cool platform where everybody can ask questions. And yeah, and maybe next year we don't have to talk about what's the problem in women in data science. We can just do hardcore AI, you know? No, I'm joking. So the last thing is that what we want to finish. Let's have some drinks and food, thanks to our amazing sponsors, and go for those amazing speakers you saw today. Ask them questions, ask them what they do, try to talk to the potential role models, and have fun. So thank you for all of you for coming, and a big applause for all of you for surviving for that long.
And see you next year.